good? Okay, so number 12, the area bounded by that equation, which looks like it's going to be a parabola, quadratic. Hey, it's factorable. That helps me graph it because I know that parabola. Does anybody know about this? It's going to be moved to the, ooh, that 2 is with the x. It's going to be moved 2 to the left. I don't want a black pen. I want a different color. Okay. And then, I thought this was done. That's correct. Parabola going up. I know it's going to hit there. There. So it's going to look like this. Okay, well, there's that problem. I don't know anything. Okay, now I'll pick up. And y equals 4. Here's y equals 4. Revolved around the line y equals 4. It's revolving around this. That's terrible. So, let me draw a better set. It's revolving around this. Okay, there it is. So it's this area that's revolving. And it's revolving around this thing. So if it's revolving around this thing, I think this right here is the radius. Would you agree that's the radius? What it's? I'm trying to figure out this thing. Well, if it's revolving around the line y equals 4, it must mean that I'm moving across in the horizontal direction, which is like the x-axis. Like the x-axis got moved up. So I at least know this. I'm going from -4 to 0. I at least know that. And I at least know I can do dx from -4 to 0. And I know it's going to be pi r squared. Well, there's r, right?
4 minus.
Looks like it's the piece inside that parabola up to 4.
So 4 minus the
4 minus the shape, or 4 minus the curve.
4 minus the curve.
4 minus that f of x or y. So 4 minus, this is the part I don't want. So if I took the integral of that curve, I'd get the area between it and the x-axis, which is exactly what I don't want.
Yeah.
And then take it away from 4. And I should get the radius I do want. Let's get rid of this part down here. Problem, it's ny, and I'm going across horizontally. I gotta put it in terms of x. I don't think that's so bad, right? I can easily change that. And I go -4 to 0. Hey, if you want to, we could just go ahead and pull the pi out front, right? That ain't gonna change. Just remember I pulled it out. And then in here, I've got 4 minus. Oh, it's right there. Y is The hard part is looking up at my picture and figuring out, okay, this is the radius. So how can I get that radius? At some point, it's gonna be 4. Oh, 4 minus this piece, which is the function. So let's clean this up a little bit. I have pi integral -4 to 0. Oh, look, I got a 4 minus a 4, so those will probably cancel. So I got minus x. Oh, look what I didn't do. Exactly what I said. Don't forget radius squared. Sorry, wait a minute. I gotta back up. No, I don't. This is fine.
But if you cancel the 4 from the 4.
Yeah, this is
but it's
fine.
4 squared.
Do what now?
You canceled the 4 with the 4 inside,
Yeah,
but it's squared.
yeah, you're right. What was that? Plus? I should look at my notes if I'm gonna do it that fast. Okay, oops. And I did it wrong. I can cancel it because that is the radius, sorry. I gotta be careful writing the radius down. The radius is 4 minus that piece. And then I wanna square that. So this is all the radius, the whole thing. That's all the radius. So I really do have 4 minus 4. So I really do have, well, let's do this. Minus x squared plus, well, why don't we just do this? I already did the 4 minus 4, so why don't I just put minus x squared minus 4? And that's gonna be
X to 4.
and I said you can use your calculator.
So you can just plug in that into the calculator.
Yeah, because I'm saying find the volume of the solid using your calculator. So this was one that they were really looking for you to set up. And then they might have given you a point for the answer. But the setup probably included 2 points, 3 points total. So let's see what we get when we put that puppy in the calculator. And I'm sorry I messed it up with the r squared. R. Sorry. I will try really hard not to make any more mistakes today. And this is one, if given enough time, we could probably minus x squared minus 4x onto minus x squared minus 4x. Spread it out, I'd have 3 terms. I could definitely take the integral by hand of this if I had enough time. Sometimes you could do it, but they let you have a calculator because they know time is limited. Anybody got an answer?
34.1335.
Oh, yeah, we could do that. I actually multiplied the pi in. I actually got this.
107.233.
What'd you get?
107. 107. 3, 3.
That's what I. So if they give you enough time to do it by hand, you just have to spread it out and then do each. I mean, the power function. It just takes time. But they let you use your calculator. Guess what? This one wasn't. Questions?
Can you explain, I'm confused on why you did 4 minus y.
Because I want this radius right here. That's what's rotating around. And it looks like it's going out here. So that's the piece I want, the radius. Well, if I did just the curve, that's always from the x-axis. So if I just did integral of the curve, it's going to give me this. Right there. Well, that's not the radius. The radius is all the way up here at 4 minus from the curve to the x-axis. It's this minus that, because I'm rotating around this. If I was rotating around the x-axis, I wouldn't need that. Because it'd be going, it would be giving me the area under there, which is exactly what I would want. In this case, it's exactly what I don't want, because I'm going this way. So this is my radius. So it's gonna be 4 minus that curve, 4 minus 4. We'll have to practice that if it's another line other than x-axis or y-axis. Well, we got this thing. Let's see, somewhere I have the notes. My notes are all messed up. Let's see. Oh no, there's no. Oh God, this is it. Yeah. Because what I've just shown you here is a bunch of questions dealing with the disc or the cylinder method. And when I rotate it, I'm going to have a solid. I mean, it is a solid. This hunk of solid. It's going to be solid all the way through. Sometimes I'm not going to have a solid. There you go. No. Forget it. It's on your paper. Okay. Here's what's going on in this one. This is a second, I mean, it's really the same method, but we call it the washer method. Because what I'm rotating here won't be a solid all the way through. It'll have a hole in it. So people like to say, oh, we're finding the volume of a donut. Okay, yeah. It's kind of over here, we're finding the volume of a donut. So, you guys are one of 5, Evie, 6 people in the entire school who could find the volume of a donut. You really could. You could find the volume.
Or do you want to eat it and then find the
So,
volume?
because this is so light, I know it's on your paper. I'm gonna try to make it a little bit darker.
Down here.
The region enclosed by the curves y equals x, well, that's a
Yes, how many?
line, right? A diagonal line. So we got y equals x. And y equals x squared. That's a parabola from the origin, right? So the region enclosed by those curves, do I see a region enclosed by those curves? Yeah, right here. There it is. Right there. And I'm going to rotate it around the x-axis. So here's what's happening. I'm going around the x-axis. Kind of like that. Here's my radius. Guess what? It's exactly like what we just did in number 12. The top minus the bottom. But do y'all see we're gonna get a hole in this when it's rotated? Before I do that.
Rotating.
I am a horrible drawer. If you had a calculus teacher who was a great drawer, I'd probably just make it. I don't know if you can see that there's gonna be a hole here. But does it look like there's gonna be a hole?
Yeah.
Okay, if you can see it, that's good. Okay. I need the area, or I'm gonna find the volume. Why don't we do that? Yeah. So I'm gonna have, the area is of the bigger one. When I do this, I'll show you this. Yeah, there's radius 1. Maybe do it in a different color. Maybe buy some new pens and actually show it right. There's radius 1. Right? But that would be a complete solid all the way through. Guess what, guys? I don't want that. Just like the last example. I don't want this piece from that curve down. If I just do this curve, I get that all the way down. So why don't I subtract this piece, just like I did? Only the last time it was 4, because it was y equals 4. This is y equals x. Same concept, right? So we got a washer. This is called the washer method because we got a hole in the middle. Okay. So let's see. Where am I? How do I want to present it? Yeah, pretty much what you said. All right. We'll do the area of the first one minus the area of the second. Is that making sense? So that's going to be, let's see, the radius of the first one goes out to the one that's on top. That's gonna be y equals x. And then I want to square it. If I were to square it, minus pi r squared. The other one's going up to the curve that's underneath, which is x squared. Squared. So that's the areas. But I want to find the volume. And I know volume is the integral. Well, let's see, from what to what? Probably 0. I gotta figure out where they intersect, what this point is. Does anybody know where they're gonna intersect? 1. 0 to 1. Again, you can just set them equally. And that would be pi take out the pi. Let me do this in little stages so you can see it. They both have a pi in common, which I can pull out,
3.14.
which I can actually pull out in front. So that ain't gonna change.
My mom said we would buy some. She said,
X squared minus 64 dx. Gives me a little something easier to integrate. So I got the pi out front. And then I've got x to the third over 3 minus x to the fifth over 5. And I want to take that from 0 to 1. I love both those numbers. I love 0 more. Because that's going to give me pi out front. Don't forget that. 1/3. 1 cubed is 1/3. Minus 1 to the fifth over 5. Minus 1/5. Minus 0 plus 0. Love me some zeros. So if I put that over 15, get that common denominator, 5 over 15 minus 3 over 15. Then I got that pi out front, don't forget the pi. Hey, whenever you do volume, just remember there's a pi. It's gonna have pi. So what is that, 2 over 15, 2 pi over 15? Units cubed. Questions on that?
Did someone say donuts?
was it pie?
Did someone say pop? My favorite.
That's true, pie and donuts.
Pie.
Pie and donuts. What'd you do in calculus today? We talked about pie and donuts.
Donut.
Where?
And how we love 0.
Yes.
I
Because when you
I don't know how to do this.
But I can't let you out of here just yet.
I don't know how to do this.
Look at number 14. Look at number 14.
My God, definitely will chuckle. I don't know how to do this.
No, well, what does 14 say?
Find the volume of the solid obtained by rotating the same region in the above example about the y-axis.
Oh.
So is it opposite of what? Okay. It's a new donut.
Is it gonna be the same volume?
No.
Probably not. So now I've gotta do this. This is where I need you guys to help me from 1 to 1. Let's see.
So 0 to like 1.
That's still gonna be 1, right? From 0 to 1, even in the y scale,
Yeah.
from 0 to 1. I'm gonna have to do it even. Which one's on top this time?
Y squared.
Or which
Yeah,
one's
yeah, yeah. X
which
squared.
one's further away from the axis?
X
Maybe
squared.
that's what I should be saying. Which one's further away? It's the y equals x squared, right? So that means x would be the square root of y. Square root both sides. That's the one that's on the top. You wanna go ahead and put the pi out here? And the one on the bottom is the line y equals x, or x equals y.
Uh-oh.
So that's gonna give me, I don't know how I can clean that up anymore, so I think we could probably go ahead and take the integral. That's y to the 1/2, which is y to the 3/2 over 3/2. Flip it. Well, if we flip it, we get 2/3. I say flip it, I didn't. Over 3/2, which is 2, minus y squared over 2. We're gonna take that from 0 to 1. Just so happens the y value 0, 0, 1, 0, 1, 0, 0, 1, 1. Just so happens the y values, they're not always good. So you always have to check to make sure your interval's going. You know, if we're doing y, it's going from what to what in y terms. It just so happens it's the same. Oh, I got my favorite 0 again. And I got my second favorite number, 1. Square root of 1, 1 cubed is 1 times, I bet that's 2/3. Minus 1 squared over minus 1/2. Minus 0 plus 0. So that's pi, probably get a common denominator here, 6. 4, 6,
1/6.
minus 3, 6, with the pi out front. How about pi over
You get 1/6?
6? 1 pi over 6.
Yo, I got you, bro.
Five.
I didn't hear you, bro.
Not the same. I get a different shape when I rotate it around the y. Don't ever assume that rotating around the y is the same as rotating around the x. Very seldom is it. That's good.